Good evening, everyone. Welcome to session. Welcome to Unacademy. Welcome to Kreatryx channel. So let's start the session on digital circuits. So learn digital in 20 hours. So we are in sequential circuits. I hope this is the lecture 7. I feel yes. It yesterday 1, 4, 5 plus 1, 6, and total 7 lectures. So let's start. I think people will join. Yeah. Okay. So an academy prices are going to rise soon. So before the price hike, if you want to take the subscription, subscribe as early as possible using the code Shankar10. Uh, so these are the rankers for GATE and ESE examination this year, 2022 ESE examination, the rankers for electrical and ECE engineering. And the new batch started yesterday, 2 days back. I've started signals and systems for you. So if you want to start your journey for GATE 2024-2025, this is the perfect batch where you get the classes of the top educators, live access to the many classes of the top educators, and you will be getting daily practice problems. Okay, you will be getting access to all the digital books, e-books, live quizzes, and many more advantages. Okay, all these you will be getting it if you join the GATE the 2024 or 2025 batch we started a few days back, Udaan and Bunyad batch. And there we have some IRMS and CSC mains batch will be there. Is also present with us. So I will give you those details also at the end of the session. So let's continue with the session first. So yesterday class में तो sequential circuit शुरू किया. In this journey of the 20 hours digital circuits में combination तो खत्म किया. Sequential में yesterday I have finished the basics of, or in fact the entire theory of the flip flop, and we have also discussed every flip flop the characteristic table, characteristic equation, excitation table, how to convert one flip flop into another flip flop. All these things we have discussed in fact, right? So let's move further. So basically, these things are done yesterday. Yesterday, I have given the propagation delay, etc. information. Today, I will give some little definitions of that also. So triggering के बारे में discuss करना चाहिए तो firstly before that, yeah, flip flop with asynchronous or direct inputs. Flip flop में generally what we have discussed, flip flop तो काम करना चाहिए तो clock is to be applied. Clock के साथ flip flop काम करेगा. But बिना clock flip flop का output हम आपको change करना चाहिए. That is, you want to make the output of the flip flop to be 0 or 1 all of a sudden. इसके लिए आपके पास asynchronous or overriding inputs होना चाहिए. Those are nothing but preset and clear. So clock can be anything. Clock can be anything. अगर preset 1 दिया तो clear is not present, output will become 1 immediately. Clock can be anything. अगर clear 1 दिया तो output will become 0 immediately. Clear means making output 0. Preset means making the output 1. When clock is available, okay, when both preset and clear are not present, normally the flip flop will do this normal operation. So this preset and clear can be active high and active low also. If it is a preset is active low, then preset is 0, it will do the job of preset. Basically preset and clear क्या करेगा भाई? It will make the flip flop output to be 1 or 0 without the intervention of the clock. Clock apply किया, नहीं किया, input क्या, ये सभी छोड़ दो. Some suddenly preset 1 किया तो immediately the flip flop output will be 1. These are asynchronous. There are some specific case called synchronous clear. That is a special case where synchronous clear is a special case. If nothing is specified, always asynchronous only. But synchronous clear is a special case where clear happens in next clock, not immediately. Synchronous clear तो special case है where it will happen in the next clock, not in the immediately. ठीक है? So this is a special case. Sometimes normally we specify clear means it will happen immediately without the what we call clock. Okay. But there is a special case called synchronous clear. So when you give synchronous clear, the flip flop will change its output to 0, not immediately, but after next clock pulse. Nothing specified. हमेशा हम clear को assume करना asynchronous only. Okay, so let's move further. So the next one, triggering. So triggering basically ये तो कल क्लास में डिस्कस किया ना, एज ट्रिगरिंग, लेवल ट्रिगरिंग, ये सभी चीज तो हो गया कल क्लास में. जनरली फ्लिप फ्लॉप का व्हाट वी कॉल स्विचिंग टाइम्स बोलते हैं इसको. व्हाट इज दिस? दिस इज स्विचिंग टाइम्स ऑफ फ्लिप फ्लॉप. EC वाला बच्चों के लिए दिस इज इम्पोर्टेंट. इलेक्ट्रिकल बच्चों डोंट वरी मच अबाउट इट. But what is the setup time is the minimum time by which the input is present before applying the clock. Input must be ready so that input will be read by the system. Our input request charging the capacitor or whatever may be there to read the input. If you give the input by minimum amount of time earlier to applying the clock, that is called setup time. After applying the input clock, we should keep your input constant for some time to read the input. That is called hold time. After applying the clock, it requires some time to get a valid output. That is nothing but propagation delay. ये कल क्लास में डिस्कस किया ऑलरेडी. ठीक है. So now let's move to registers. So registers के जाने पहले shall we do few problems then go to registers? It will be better, I think. So we'll go to the registers theory. Before that, let's do some questions. So problems based on yesterday class. चलो फर्स्ट क्वेश्चन. आई होप यू पीपल कैन आंसर दिस क्वेश्चन. है तो थियरेटिकल क्वेश्चन है. एक मिनट टाइम ले लो, गिव इट ट्राई. टाइम अप. नो आंसर. क्या हुआ यार, ये तो आसान क्वेश्चन है, इसमें भी दिक्कत है क्या? Consider the following conditions. TP is the pulse width. The pulse width is TP. Delta T is the propagation delay. What is the condition to avoid race condition? My delta T should be greater than the pulse width, less than the time period. This is what we have discussed yesterday. So delta T must be greater than the pulse width. Delta T should be less than the T. So 1 and 2 must be satisfied to avoid the race condition. ये कल ही discuss किया class. Next question. So this is a simple theoretical question. Master slave flip flop is also called as pulse triggered flip flop. Next. So this is a good question. Give it a try. So please try this. Please try. 27 seconds more. Timer. Okay. So what is the equation of the D flip flop? Qn plus 1 equal to D. Here what is your D? Q bar. So that is Qn bar. This is the toggle condition. So toggle condition, D flip flop is connected in the toggle condition. Now what happens? See here. Suppose this is my clock. This is my clock. Positive edge triggered. A mirror clock. Okay. Now positive edge triggered. Next. So the output Q toggles on every clock pulse. This is initially 0. First clock pulse it becomes 1. Next clock pulse it is 0. Next it is 1. Next it is 0. Because it is a previous every clock pulse it will complement the output. Now if you take this time period as T, what about this time period, sir? T naught is equal to 2T. So my frequency F naught, if time period is multiplied by 2, F naught is equal to F by 2. Frequency is divided by 2. So 10 kilohertz will become 5 kilohertz. And this circuit is called frequency divider circuit. Whenever your output is equal to toggle condition, it always works like a frequency divider circuit. Whenever Qn plus 1 is equal to Qn bar condition happens, output of the flip-flop is in the toggle condition, then it is always working like a frequency divider circuit. Input clock frequency will be divided by a half in the output. This is one of the application of the flip-flop. And you can use this, here it will generate two signals. This will also divide, this will also divide. Two signals with 180 degrees phase shift. Okay, because Q bar are complementary to each other. One more thing, you can use another flip flop, it will divide further by 2. Like that, you can divide to your requirement. Right? Chalo, let's move further. Next question. This is also a doable question. ये क्वेश्चन तो कर सकते हैं आप लोग. Sure. Here, yesterday class we have discussed what we call conversion of the flip flops. Na? So this is Q, X XOR with Q. What is Qn plus 1 in the D flip flop? It is equal to D. What is the D input here? X, Q, XOR with X, or Qn plus 1 is equal to X XOR with Qn. It is similar to T XOR with Qn, which is the characteristic equation of T flip flop. So it is implementing T flip flop indirectly. Directly it is implementing T flip flop. I already told yesterday class में Qn plus 1 equal to D. So D flip flop में if you want to implement any flip flop using D flip flop, make D input is equal to the characteristic equation of the desired flip flop. Next question. Okay, this is the conversion of the flip-flop. This also we have discussed yesterday class, the same model. Please give a try. How to convert one flip-flop to another flip-flop I have given yesterday class. Okay, characteristic table of the desired flip-flop followed by excitation table of the available flip-flop. Use that concept and give a try. Time up. Okay, let me do it. Here, the process is the characteristic table of desired flip-flop. आपको कौन सा फ्लिप फ्लॉप चाहिए? ए बी फ्लिप फ्लॉप चाहिए. सो ए बी फ्लिप फ्लॉप में ए बी क्यू एन प्लस वन. ठीक है, यू टेक ऑल जीरोस टू ऑल वंस. ठीक है, characteristic table of the desired flip flop. Here, as we have seen in the previous slide, as for example, when AB is 0, 0, Qn bar 1, Qn 0. So Qn bar 1, Qn और 0. ठीक है, so Qn bar means 1, 0, 1, Qn और 0. Now listen here, followed by excitation table of the available flip flop. Excitation table of the available flip flop. What is the excitation table of the available flip flop for JK flip flop for 0, 0, 0 cross 0, 1, 1 cross 1, 0 cross 1, 1, 1 cross 0. So 0, 1, 1 cross 1, 0 cross 1 are the inputs to be given. This is excitation table which we have discussed yesterday. Okay, so here so for J, if you take A, B, Q, N, for K, if you take A, B, Q, N, ठीक है, you can make one pair here, pair here. हो गया काम. So J equal to A bar, K equal to A bar, B bar plus AB. That is nothing but A X naught. 1 minute please, 1 minute. So here examiner का input J input चाहिए. So इतना करना क्या चाहिए सर? चाहिए क्या? इतना तो करना नहीं चाहिए. Sometimes it is possible to solve it very easily without doing all these things. वो शॉर्टकट दे रहा हूँ, ध्यान से देखो. एग्जामिनर को क्या चाहिए? ये वाला काम करना चाहिए using JK flip flop. Take JK flip flop here. When will you get QN bar? When you give 1 1. So when you give 0 0, JK flip flop में You are implementing JK flip flop, AB flip flop using JK. So for JK to get QN bar, when I give AB 0 0, internally it should go 1 1. Similarly, to get 1, what is the input I should give? 1 0. QN के लिए 0 0, 0 के लिए 0 1. These are the inputs it should go for 0 0 0 1 1 0 1 1. So what is the equation for J is very simple now. It is 1 for 2 cases. What are they, sir? A bar B bar plus A bar B. That is A bar. For K, A bar B bar plus AB. A X naught. That's all. Without doing this much, you will get the answer within one single step. This is true or possible whenever examiner asks you using JK flip flop, or when the truth table already contains what the truth table of the JK is already existing. Okay, so this is the simplest way. So let's move for the next question. So you can use our regular method, that is the characteristic table of the desired. This is the characteristic table of desired, and this is the excitation table of available. You can also frame its characteristic equation and equate both and do it. That will also give you the same answer. So let's move for the next. So this is also one more similar question to what we have done in the D flip flop wala case. So give a try for guys. This question could be in the circuit shown in the figure. Q equal to 0 initially. What shall be the subsequent state of Q when the clock pulses are given? 1 0 1 0 1 0. Okay. 0 0 0 0. All ones. 0 1 0 1 0 1 0 1. Please try. Please give a try. Please give a try. 10 seconds more. It is an easy question here. If you have attended yesterday's class, you can definitely answer this easily. Listen, here, what is JK flip flop characteristic equation? Qn plus 1 equal to J Qn bar plus K bar Qn. What is the J input? 1. K input? Q in this figure. So substitute that Qn plus 1 equal to J Qn bar plus K bar Qn. That is nothing but Qn bar. It is called toggle condition. So इसमें क्या होता है सर? Initially it is 0. ठीक है? So after first clock pulse it will become 1. Second clock pulse 0. Third clock pulse 1. Fourth clock pulse 0. Fifth clock pulse 1. Every clock it will toggle. नहीं है तो you can directly do like this also. Initially यहीं पे 0 ले लो, यहीं पे 1 है ना, 1 0 will give me output में 1. That 1 will come here. Again 1 1 will give toggle. That 0 will come here. 1 0 will give me 1. That 1 will go here. 1 1 will give toggle. Like that also you can do the analysis by taking initial 0, and we should start. So excluding the initial, what is the output you are getting is 1 0 1 0 1 0. This is also a frequency divider circuit, as I have discussed earlier. Whenever the output Qn plus 1 equal to Qn bar, it will work like a frequency divider circuit. So let's move further. This is a counter, register, register, register. Okay. So I think those are the questions from flip flops. Okay, you can try this question. This is a Let me little expand this. Right. So listen. Please try. At 30 seconds more. Last 10 seconds. Yeah, you can join. After, 10-15 minutes, I start new topic register. So consider the following circuit involving a positive triggered D flip-flop. Okay. So it is a D flip-flop. So what is the expression for D flip-flop? Here, AX and Q bar X bar. Okay. So what happens is, what is D is equal to AX plus Q bar X bar. When x equal to 0, your D is equal to x0 hai to 0 bar is 1 na, this is 0, you get Q bar. Okay, previous bar. When x equal to 1, your D equal to A because this part 0 and you will be getting it. So this is the condition of the circuit. So at the positive edge, when x equal to 1, this is the x. When x equal to 1, it will read the input. What is the input you are applying? Maybe here at the 0th clock pulse, you have given A naught. So first output is A naught. So these two are wrongs. Okay. So after the first clock pulse, output will be equal to A naught because when x equal to 0, okay, before this x equal to already 0 na, so it will already give you A naught here. Next, when x equal to next first clock pulse ho gaya, next clock pulse mein here it is transiting from 1 to 0. Okay. Uh, Otherwise, you take this as the first clock pulse. So in that case, you get EM1 na, because he is taking this as the first clock pulse. First clock, second clock, third clock. This is fourth, fifth. This is before the clock. Okay, A1 will come here. Now, if you take this as 1, A2 will come. If you take it as 0, previous value का complement will come. Qn bar आ रहा है ना? Qn bar. So, if you take 1, you get A1 के बाद क्या हो रहा है? Just a minute. if nothing specified, you take final value here, x equal to 0. If you take it, then what will you get? So initially it is at a naught. For example, this is a1. You get a1 bar here. Again here, x equal to 1, it will read a3. Again, x equal to 1, x equal to 1, it will read a4. Here x equal to 0, it will complement the previous value. So it is equal to a0, a1, a1 bar, a3, a4, and a4 bar. So option A is the right answer. Next, let's do this question which will complete the flip-flops. Then I will start the new topic, registers. Maybe I will take 2 more classes for this digital, that will finish the sequential circuits. Data converters, I will think whether I can take the data converters or I may be, what I can say is I can provide you the recorded content, though I will provide you because I promise. I have seen many students, this is very disappointing, is when I make a shot, I ask how many of you are really interested. Many students said, I need sir, I need sir, but class शुरू करने के बाद कोई नहीं आया. ठीक है? Please don't do this here. This will definitely, what we call, this sort of behavior to encourageable night because of you people. If you are not really sincere, don't comment that you are going to come to the class because of you. If someone start an initiative, lot of efforts we are keeping, that energy I can keep somewhere else where some other students may get benefited because of your people false comments. Others, I mean, instead of you, I can give, I mean, instead of this, might have given some other initiative, I can give to many other students may be able to learn because of that. That is the intention. So maybe I have committed because of that. I am giving this content, but in the back end, मेरे को भी doubt आ रहा है why I am giving this much energy. Okay, when the people are not really serious about the class, why should I give? When the other end is not really interested, why should I waste my energy? ऐसा सोच रहा हूँ, but एक वक्त तो दिया मैंने. I will be completing the syllabus because of this. Okay, even few students are there. Whether some people might be watching and recorded in the back end, that I don't know. I am continuing this. Okay, but tomorrow, day after tomorrow, तो sequential तो complete हो जाएगा. So data converters, the last chapter of electrical. What to do, I will think. If possible, I will give it. Otherwise, I will provide a marathon session which I have already recorded. That I will add it in this playlist. That will also complete the syllabus so that I can work on some other initiative which can help to the students. Okay, chalo, let's see. So let's do this question. This question is little tricky for you guys. It's not that easy. Please try. Thirty seconds more. Chalo, next. So here, I think you need an inverter here. So this is 1 0 0 0 0. Okay. Now please see, this is a NOR latch. Here Q is available means opposite end पे S होना चाहिए, R होना चाहिए, ठीक है. And this is your clock C, and this is your D, and this is D bar, and this is C. Now please listen, it is just SR NOR latch only, with S input is equal to what? S input is equal to C plus D bar. R input equal to C plus D bar whole bar. Now what are CD initially? C and D initially 1 0, then it will become 0 0, then it will become 0 1. Placement of S must be proper because Q is at bottom, S must be in the top. That is yesterday class तो मैं explain किया ये. So C plus D whole bar is 1, whole bar is 0. C plus D bar is also 0. Okay, let's see. I think some mistake is there. C plus D 0 plus 0 0 whole bar is 1. Okay, then C plus D bar 1 whole bar is 0. Then here also C plus D whole bar is 0, and C plus D bar 0 plus 0 0 whole bar is 1. So this will become 1 0. Okay, so read the question here. For the circuit shown in the figure, uh, D has a transition from 1 to 0, and clock changes from 1 to 0, D changes from 0 to 1, gate delays are negligible. Which of the following states are 0? Q goes to 1, this is your Q. Q goes to 1, suppose you take it as a no change. Q goes to 1 when, what happens when clock becomes 0? Q goes to 1 on the clock transition, correct. And stays at 1, no. Q goes to 0, no. Q goes to 1 at the clock transition and goes to 0 when D goes to 1. Perfect. When D goes to 1, it again goes to 0. Q will become 1 when clock becomes 1, when clock changes from 1 to 0. When D changes from 0 to 1, again it will become 0. Option C is the right answer. Right? Chalo, next. Now that will finish the flip flops. Okay. Now we are starting the new topic, that is registers. Right? So that is about your flip flops. Now we see the next topic, that is flip flops. Just registers. Just a moment. Right. Now this is a new topic. So registers are a group of flip flops cascaded together to store the data. ठीक है? Register flip flop तो एक bit store करेगा. अगर आपके पास n flip flop cascade together with a common clock, then it is called as a what we call register. Registers are a group of flip flops cascaded together to store the data. ये n bit register के पास कितना flip flops होता है सर? n flip flops होता है सर. If you have a n bit register, you will be having n flip flops. Based on the applications, generally registers will be classified as shift registers and storage registers. But based on the input and output, registers are classified into four types. What are they? SISO, serial input, that is input is given serially bit by bit and output is taken serially bit by bit. Okay, right? Counters tomorrow. Okay. SIPO, serial input, parallel output. Next, PISO, Parallel input, serial output. PIPO, that is parallel input and parallel output. These are the different what we call a type of registers we are having, right? So let's start with the first one, SISO, 4-bit right shift SISO. So here, this is an example of serial input, serial output, shift register. Here we apply the see if you have doubts, you should attend live and ask me. Okay, when other topic is going on, if you ask me the doubt from previous topic, I cannot stop the lecture and explain it. Attend the classes in live and ask your doubts in the live. नहीं है तो एक काम करो, मेरा special classes पे आओ, there we can discuss the doubts. Okay, चलो. Now listen here. Serial input, serial output. Suppose I want to give the data 1101 here. First, we apply LSB. LSB is applied first here. Then we will take the output here one by one. So what happens is you take here the serial data okay and the clock. So initially maybe all zeros you write. What happens is when you apply the simply how it is doing the shift operation. When you apply the clock, this bit will come here. Next, when you apply the clock, this will come here and the new bit will come here. The same way, next clock पे this will come here, ये यहीं पे आएगा, the new bit will come here. The last clock pulse में this will come here, this will come here, ये will. This is how the data is getting shifted in the right. So first clock pulse when you apply, this input में first bit will come here. And the remaining Q3 is the input to the next flip flop na, that will come here. Q2 is the input here and Q1 is the input here. Next, this 0 comes here, 1 double 0. Next, this 1 comes here, 0 1 0. Then this 1 will come here. Then what happens? 1 will come here, 0 will come. So 4 clock pulse, it will change. The data 1101 will come here. After 4 clock pulse, 1101. This is, it requires n clock pulses to read the input. After reading the input, now listen here. First, after 4 clock pulses, this 1101 will appear here. Now I will read the output from here. First bit come. When you apply the next clock pulse, this becomes 0 and these will be shifted. Next clock pulse, this becomes 0, remaining 3 will be shifted. Next clock pulse, this becomes 0 and this will be shifted. If you read like this, that 1101 comes from the last bit. So it requires the first clock, already fourth clock pulse, when you apply the input itself, first bit comes. So the remaining n minus 1 clocks are required for reading the output. So SISO pay, what is the use here is once you apply the input, it requires n clock pulse to transfer that. So it will be used to generate delay. It will be used to generate delay. Input requires how much time? N clock pulses. Output requires n minus 1 clock pulses. Okay, so this is the SISO circuit. Now, if you make the connections reverse, यहीं पे input apply करो, ये इसका output यहीं पे connect करो, इसका output यहीं पे connect करो, इसका output यहीं पे connect करो, then it will give me SISO in the right shift. Okay, so okay, if we reverse the connections, we get what we get. अगर ये connections उल्टा किया तो we get left shift register. ठीक है. Now the next one is SIPO, serial input, parallel output. Here output is taken parallel, but the input is applied bit by bit. So this is a parallel output. ठीक है. So input is applied serially, but output is taken parallelly. Same story, but here all bits are taken same time. Parallel output. So it requires no clock pulses. Okay. So here it is used to do serial to parallel conversion. We give input bit by bit. We take the all bits at a time in the output. It is also called temporal to spatial conversion. Okay. So your input requires how many clock pulses here? N. Output requires no clock pulse. That is about your the next one, SIPO. So let's move for the next one, that is PISO. Here input is applied parallelly, okay, and output will be taken at the last value only, serial. Here input apply करने के लिए you require one clock pulse. Output requires, see here, input all bits we apply at the same time. Then we take the output bit by bit at the end. Once you apply all bits, first bit will come out. The remaining n minus 1 bits requires n minus 1 clock. It will do reverse job. Parallel to serial conversion. That is your spatial to temporal conversion. Last one is last type of register we have is PIPO. Say this is your PIPO. Parallelly we give the input, parallelly we take the output. So here it is not shift register, it is storage register. What is this? Storage register. Just to save the data we use it. Input requires one clock pulse. You keep the input, apply clock, it will save. Then you get automatically the output. No clock is required. Right? That is about your PI PO. Generally, arithmetically, If you have some data 1,000, if you do right shift, it will become 0,100. Another right shift, it will become 0,010. Another right shift, it will become 0,001. Another right shift, it will become 0,000. So value 8 will become 4, 4 will become 2, will become 1. Okay. So here it is nothing but arithmetically division by 2. Similarly, you have 0,001, left shift 0,010, another left shift 0,100, another left shift 1,000. So this is 1, 2, 4, 8. This is equivalent to multiplication by 2. Okay. What is that M? M is argx. If how many functions you need to implement, those many argx required. Right. Listen here. Parallel input, parallel output is also there. This is normal shift register के बारे में discussion. Okay. There is one more thing called universal shift register. That is a single register which can do both right shift and also left shift. यूनिवर्सल शिफ्ट रजिस्टर क्या करते हैं भाई, वो लेफ्ट शिफ्ट भी कर सकते हैं, राइट शिफ्ट भी कर सकते हैं. ठीक है. सो जस्ट कनेक्शन उल्टा करने के लिए हम मल्टीप्लेक्सर यूज करेगा. इट कैन ऑपरेट इन 4 modes. That is right shift, left shift, parallel load, that is to store the data, and there is a standard universal shift register, clock inhibit. Clock inhibit means it will not do anything, just to save the data. Okay. So that is about your registers. Okay. There are 2 more. See here, we can implement these registers using D flip-flop, JK flip-flop, any flip-flop, but it should work like a D flip-flop. Whatever you give, it should save. इसके लिए JK से भी कर सकते हैं, but here J और K के बीच में converter लगाना नहीं है, तो Q bar connect करो, it will work like a D flip-flop. So we can use any flip-flop, okay, but it should work like a JK flip-flop by connecting Q bar. Okay. So there are 2 more things we should discuss. Before that, let's do few questions and come back. Right? Try this question. Those who are in the live, give a try. There is a register here where output is connected through exclusive OR gate to the input, 4-bit shift register. Okay. So D is given to A is given to B, and so on. The present state of the shift register is 1101. The number of clock cycles required to reach 1111. Try this question. Time up. A, B, C, D. Initially 1101, and A and D are done XOR operation to give back here, and you have a clock. So when okay, let's continue. So here, when you apply the first clock pulse, this 10 will be XORed and given as input. Baki will be copied as it is. Second clock pulse, these two are XORed and remaining three shifted. These are, sorry, the initial value गलत ले लिया. ठीक है, now चलो. First two XOR 0 will come, these three will be shifted. 0 will come, these three will be shifted. 0 will come 1 and the remaining will be shifted. 0, 0, 0, next 1, 1, next. These two XOR operation is 1, double 1, 0. These two XOR operation 1, 1, 1. So how many clock pulses are required? How many clock pulses are required to get double 1, double 1? 10 clock pulses. Please try it and comment your answer here. Without trying, you don't get anything. So next question. Try this same model. Try. Right. See here. Again, same story. 0, 1, 1, 0. These two are XORed and given as the input. So this is the clock. When the first clock is applied, so after 3 clock pulses is asking now first clock pulse means XOR operation of this is 1. XOR operation of this is 0. XOR operation of this is right. So after 3 clock pulses 1 0 1 0. Right? Chalo, next. This is done. Try this question. Try this. Okay, take your time. Try. This is a good question, yeah. First, read the question. Understand the question. Question ज़्यादा lengthy है तो don't think it is too difficult. Answer will be easy always. Most of the cases. Right. Time. So here first understand the question. The circuit shown A is a parallel input, parallel output register. Clock is the positive edge triggered. Okay. So how many positive edge triggers are happening? Here first edge, here second edge. Two clocks are happening. So which loads at the rising edge of the clock. The input lines are connected to the 4-bit data bus. Okay. Uh, the ROM output is floating and enable is 0. But here enable is 1, don't worry about it. And a part, so when enable is 1, if this is the address, this is the data of the ROM. Here we are giving the address. Here you will be getting the data inside the ROM. This is the address and data given by examiner. So if the at time t equal to t1, you have 0, 1, 1, 0. So this is the initial content. Initially you have 0, 1, 1, 0 at time t equal to t1. So when you apply the first clock pulse के बाद PIPO will transfer this. Then 0, 1, 1, 0 means 6. Sixth location पे data क्या है 1010. So ROM will transfer 1010 here. So this bus will get 1010. This is what happens after the first clock pulse. Then this 1010 will be waiting here. When I apply the second clock pulse, 1010 means how much? 10. 10th location पे what is the data? 8. 1000. That 1000 will come here. Then he asked up to second clock pulse only. Na? So what is the data of the bus? 1000. That much simple question. Okay, first clock pulse में 6 is available initially. Sixth location that 6 will come after first clock pulse. Sixth location का data will come here. You should read like this. Okay, that will come here. Okay, 1010. After 1010 will come appear here. That 1010 will be sorry. So here 1010 will whenever second clock pulse is applied, that 1010 will come here, and 1010 means the 10th location data will be coming into the bus. He asked up to the second clock pulse. What is the data in the bus? 1000. Okay, next. We'll do few more questions little later. Now let's try the next two parts called ring counter and Johnson counter. Those are the important applications of the registers. The ring counter and the Johnson counter. ring counter. So ring counter is very simple. The output of the last flip-flop of the SISO, serial input, serial output, is connected back to the first input. This is called ring counter. What is the ring counter? Output of last flip-flop of SISO is connected back to first flip-flop. Then it is called ring counter. Output of the last flip-flop is connected back to the first flip-flop. Then it is called as a ring counter. Okay, chalo. How it is working? Let's discuss its working operation. Q3, Q2, Q1, clock. When clock is 0, all are zeros. When first clock pulse is applied, maybe we remove this wire and we apply some 1 here initially. Then you will get 1 here, baki to zeros. First one is manually applied zone. Now second clock pulse may what happens? This 0 will come back and these 3 bits will be shifted. Then 0 will come back, these bits will be shifted. 0 will come back, these will be shifted. 0, this 1 will come back, remaining will be shifted. This is what happens. So, after every 4 clock pulses, it repeats the sequence. After every 4 clock pulses, it repeats the sequence. So, it has n different states. So the number of used states means total possibilities with 4 bits is 16 or 2 power n. इसमें you get n states are available in the output, remaining are not used. So used states are n. Unused states 2 power n minus n. Here the output frequency equal to f clock by n. Okay, this is the what we call ring counter. So here, if you plot the clock, so this is my clock. What about Q3, sir? In the first clock pulse, it is 1, remaining all clock pulses, it is 0. 1, 2, 3, 4. What about Q2, sir? Second clock pulse on, remaining all, it is 0. Q1, third clock pulse 1, remaining it is 0. Q0, fourth clock pulse, it is on, remaining it is 0. So all of them, suppose if you take the time period is equal to T. What is the time period of this? 40. Okay, all of them are having f naught equal to f clock by 4. What about all signals are shifted version of each other? It is shifted by, suppose this is a T naught. What is this part? T naught by 4. So the total phase shift is 360 degrees for one time period. If you shift by 1/4 time period, what is the relative phase shift between these two signals means 360 by 4, that is 90 degrees. So relative phase shift 360 degrees by n. 360 degrees by 4 in this case, 90 degrees. And what is the duty cycle of the output waveform? What is the meaning of the duty cycle? It is on time by total time. Total time to 4t is how much time it is on? 1 is 1 for t. So t by nt into 100%. So 100 by n%. That is 100 by here 4, 25%. These are the properties of the ring counter. Why should we use this ring counter, sir? To rotate one like a ring. Suppose four different devices are connected at the output. You want to activate only one device at a time. इस केस में आपको ring counter help करेगा. Output of one device and next device. So in scheduling algorithm, etc., it will help. It can also generate the signals of same frequency with different phase shift. You can generate three-phase signals if you have n equal to 3, and you can generate the polyphase signals with the n equal to different values of the n, can generate different signals with the frequency, with the relative phase shift of 360 degrees by n. In applications like stepper motor, etc., it will be helpful. Okay, so that is about your ring counter. You can also initially, you are giving this one here, we are applying this one initially manually. So you don't want that, you just take a NOR operation of these three and connect it at the input. If you take a NOR gate here of these three and connect at the input, whenever these three becomes 0, automatically it will give 1 for the first initial startup. Otherwise, initially if you give 1, the preset is input is available, give preset, it will make 1, then it will rotate automatically. This is about the ring counter. What is this? Ring counter. Now let's move and discuss the next one, the last one in our discussion of the registers, that is Johnson counter. Okay, so let's discuss that. Twisted tail ring count. Right. This is called twisted tail ring counter or Johnson counter. Complement of the last will be connected to the input. Q naught bar. Okay. So instead of Q naught, if Q naught bar is connected as input, then the Johnson counter will come. Okay. Complement of last connected as input to the first. Complement of the last flip-flop is last output, connected as input to the first flip-flop. Now what happens? Let us see. Q3, Q2, Q1, Q0. Take inverter and connect it back. So initially it is all zeros. Okay. When you apply the first clock pulse, 0 bar will become 1. Second, this 0 bar will become 1. Third, this 0 bar will become 1. Fourth, this 0 bar will become 1. Fifth, 1 bar will become 0. Sixth, this 1 bar will become 0. Seventh, this 1 bar will become 0. This 1 bar will become 0. So we started with 0, 0, 0, ended with 0, 0. So it will become, it has 8 states. You can also say 2n states. It is also called some sort of pattern generator or pseudo random sequence generator. It is generating some sort of sequence generator. It is also generating a unit distance code. What is unit distance code, sir? Between, you see, any two adjacent numbers, only one bit is varying. Between any two adjacent numbers, only one bit variable. Between any two adjacent, only one bit variable. Any two adjacent, only one bit variable. So here, used states 2n, unused states unused states 2 power n minus 2n. Here the output frequency equal to f clock by 2n. There n, here 2n. Relative phase shift (360° by 2n. Duty cycle, there it is 100 by n, but here that is not the case. It is 1 for 4 clock pulses, 0 for 4 clock pulses. Any signal same, 1 for 4, 0 for 4, 1 for 4, 0 for 4. So you can say his case made duty cycle is equal to 50%. On time and off time are equal. Okay, so that is about your next one. It is generating a semi-random sequence now, 8, 12, 14, 15, 7, 3, 1, 0, some sort of random sequence it is also generating. So this is called as Johnson counter. Here in ring counter, there is no need to decode the output, because if a particular bit is 1, we understand it is a new state. This is 1, this state, this is 1, this state, this is 1, third state, this is 1, last state. But Johnson pay is a 9. Johnson pay, it is 1. Suppose if it is 1, you cannot say which state it is, because it is 1 for many number of cases. It is 1 for many number of cases. So if you read one bit, you cannot say which particular state it is. Why should I say, sir? Because I want to activate one device for one state. एक स्टेट में एक डिवाइस को एक्टिवेट करना चाहिए, तो उस केस में मे बी इट इज नॉट feasible to do this with directly taking the output. इसलिए for Johnson counter output, to read that output or to understand the output, we use decoding gates. I will explain that. want to design the decoding logic of the Johnson counter. Q3, Q2, Q1, Q0. It will start with all zeros. Okay, say 0 to 7 states it is available. How to understand is one simplest way is read all the 4 bit. Whenever all are 0 state 0, whenever 1 triple 0 state 1, like that we can design the decoder by taking Q3 bar, Q2 bar, Q1 bar, Q0 bar, Q3, Q2 bar, Q1 bar, Q0 bar. That is also okay. But another way is no need to read all the bits because all states are not used. If you observe in this 8 states, this bit is 0 and this bit also 0 happens only for state 0. Similarly, this 1 0 will happen only for state 1, never any other make high 9. So there are uniquenesses in each state. The uniqueness of this state is Q3 bar, Q0 bar, Q3, Q2 bar, Q2, Q1 bar, Q1, Q0 bar. So Q3, Q0, Q3 bar, Q2, Q2 bar, Q1, Q1 bar, Q0. Okay, so here, see, flip-flop में bar is directly available. You can take like this, one AND gate, or you take NOR operation of Q3, Q0. Okay, because Q3 into Q3 bar, Q0 bar is equal to okay, you can use like this. Similarly here, Q1 bar, Q0. You can use. So this will define state 0. This will be used for state 7. So what we can say is to decode the Johnson counter, to decode Johnson counter output, we need 2 input gates only. Okay, they can be AND gate or NOR gate. So 2 input gate is sufficient to decode the Johnson counter output. Okay, so these gates will tell in which particular state the Johnson counter it is. Okay, chalo. That is about your Johnson or entire registers. Today we have done with the registers. We'll do a few questions and end the class. Okay. So we started with the flip-flops discussion. Then I have explained about asynchronous arity input, triggering, setup time, etc. Then we started the registers. Then we have discussed all the possible registers. Then universal shift registers, ring counter, Johnson counter, and its decoding. So you can make the ring counter is used to generate the signals of same frequency of different phase shift. These are the applications of the ring counter. It is used in stepper motor applications. It is used in scheduling algorithm. So normal ring counter में disadvantage क्या है भाई? It is not self-starting. Every time we start the ring counter, we need to apply 1. So we can overcome that by using self-starting ring counter. Self-starting ring counter में क्या होता है sir? If you take a Q3, Q2, Q1, Q0, ये तीनों एक NOR gate को connect किया तो and connect the input like this. This will become self-starting ring counter. Because initial one it will generate on its own when because all 3 zeros it will give 1 automatically. Okay, right. All 4s don't take it because all 4s happens only initial. After that it will not happen. Right. So that is about the ring counter. Now let's see all the problems. Right. First question. This is a 3-stage Johnson counter. What is the output frequency? I hope you can do it very easily. So please comment your answer. Here, because it is a Johnson counter, why how you say Johnson counter? Q bar is connected to J naught and Q is connected to K naught. This is a JK flip flop using the counter flip ring counter or Johnson counter using JK, because Q bar connected, they will work like a D flip flop only. But here, very important, don't think F naught equal to F by 6, because 1 0 1 is the initial state. Na? Initial state also matters. When you apply clock, first clock, this 1 bar will go here, 0 1 0 will come. Second clock, 0 bar will go here, 1 0 1. Third clock, 1 bar will go 0 1 0. Fourth clock, 1 0 1, and so on. So it is having only two states. So only what is your output is F naught equal to F clock by 2. Normally, if you start with all zeros, F clock by 2n will come. That will give you 3 into 2. What is 6 is the answer, but that is wrong in this case, because the initial condition is 1 0 1. So be careful. Right? So here option D is the right answer. For ring counter, C normally. For Johnson counter, it is D, not B normally. But his case may, because of initial value, it changes the answer. He has given that it is a Johnson. Okay, give a try for this question. So the statement is, determine number of clock required to get Z equal to 0 again. You can comment your answer. So the top one counter, another one, both are connected in that fashion. You need to find the answer. So listen. Here, this is a ring counter. Q is connected now. A ring. This is Johnson. OR गेट का आउटपुट 0 होना चाहिए, तो सारे जीरोस होना चाहिए, then only you get OR गेट आउटपुट equal to 0. Means XOR आउटपुट में both must be same, then only you get 0. That is, if QA equal to QA dash, it is not complement, output of Johnson counter, output of ring counter, QB equal to QB dash and QC equal to QC dash, then only Z equal to 0. So let's start here. This is the required condition here because our XOR gate output will be 0 when both inputs are same, and this OR gate output 0 when all the inputs are zeros. So now you apply clock 0, Q A, Q B, Q C, Q A prime, Q B prime, and with inverter it is connected because your bar is connected back, right? So we start with all 100 initially. 1, 2, 3, 4, 5, 6 clock pulses. When all of them are equal, you get Z equal to 0. Now 0, 1, 0, 0, 0, 1, 100, 0, 1, 0, 0, 0, 1, 100 is what you get. Here, complement of this 110, 111, 011, 001, 000, 100. You see, both will be same again after how many clock pulses? 6 clock pulses. This समय तक all are zeros. All are zeros up to this. Okay. Alright. So how many clock pulses are required to get back again 0? 6 clock pulses. Because both are same after again 6 clock pulses. Right. Next. There is one more question. Last question. If you are able to do this question, it is very good. 2016 GATE में दिया. So last question of the today's discussion. Assume that all the digital gates in the circuit shown in the figure are ideal. The resistor R is 10 kilo ohms and the supply voltage is 5 volts. The D flip-flops D1, D2, D3, D4, D5 are initialized with the logical values of 0, 1, 0. The clock is having 30% duty cycle. The average power dissipated in millivolts in the resistor. Firstly, this duty cycle is not having any importance. Okay, छोड़ दो, क्योंकि it is edge triggered flip-flop. Edge triggered flip-flop will work at the edge of the clock, whether the width of the clock, width of the pulse is 30%, 40%, 50% doesn't make any sense. So don't worry about that. No? So what is the average power dissipated? Firstly, understand it is a ring counter or not. Output of the last flip-flop is connected back. Remaining is the output of one connected to another. Okay, sir. So here Q3, Q5 are given to OR gate. So first, let's draw the output. Q1, Q2, Q3, Q4, Q5, and output is connected in this fashion. clock 0 पे 01010, ठीक है, 1 0 will come here, 0 will come here, remaining shifted, 1 remaining shifted, 0 the remaining shifted, 1 remaining shifted, 0 and the remaining shifted. Okay, so this is what happens after every 5 clock pulses. The sequence will repeat. You see, whatever we started, we came to the next. Now, OR gate output is Q3 plus Q5. What is Q? Q3 plus Q5 0. Q3 plus Q5 1. Q3 plus Q5 0. Q3 plus Q5 1. Q3 plus Q5 1. Q3 plus Q5 0. Taken. So, if you observe the OR gate, this is the condition. Now, when it is 1, examiner has given 5 volts, 0 it is 0 volts. Firstly, what is the average power? It is VRMS whole square by R value. What is XRMS of any signal? Root of mean of square of a signal. Is it clear? Integral 0 to t x square of t dt. Now, what is your output waveform? This is like this. It is 1 for 1 clock pulse, 0 and again 1, 0, 1, 1, 0. Okay. So this is a t, this is 2t. Okay. So indirectly, this is 5t. That is your time period of the output. Output ka time period. Now listen here. What is the, this is how much given by examiner. This is 5 volts and 0 volts. What is VRMS? You can also say this is equivalent to this signal. It is on for 3t, off for 2t. Okay. It is same, both area wise same. So RMS point of view, both will have same RMS. Okay. If you have this kind of signal. So I assume this one. So what is VRMS is 1 by total time period. How much time it is on? 3t x square of t dt plus 3t to 5t. What is its value? 0 square dt root of. Okay. Then what is VRMS whole square? That will give you 25 by 5. Square it, you get 5 square, 25 into 3t by 5. Okay, so if you square it, root to chalega. So this is 25 into 3t by 5t. That will give you 15. Power equal to VRMS whole square by R. 15 by 10k. 1.5 milli. ये वाला पूरा except the first part, the remaining entire part is network analysis का part है. Suppose this is the output waveform 1 0 1 1 0. Okay, I am saying if you take 3 ones and 2 zeros, okay, both of them, for both of them RMS value will be same. For making analysis easy, I took this and I have done the analysis, okay, by using the formula of the RMS value. Okay, power equal to VRMS whole square by R. So what is the answer is 1.5 milliwatts. Here the examiner intentionally gives that duty cycle it is of no use. So that will finish your registers. Tomorrow we start with the counters and that will finish the sequential circuits. We will do one extra class for problems or practice questions on counters of the sequential circuits. That will finish the what we call sequential circuits. Okay, that's all. So good number of questions we have done today. Okay, you can join the Unacademy new batches. Use my code Shankar10, which can give you the maximum possible discount and the best possible classes. Okay, so you can also join the IRMS CSC mains wala batches if you are preparing for IRMS examination or CSC mains examination. You can take the combo of GATE and UPSC GS wala combo leke. You can continue your preparation. Okay, so combat exam is there the day after tomorrow. Don't miss this examination. You just check your performance and there is a chance to get the scholarship here. You can write the exam based, even top 500 students will get a great scholarship to join an academy, or the last 2 months you may get a chance to get a free subscription and continue your preparation also. So write these two exams, check your relative performance and also rectify it, so that at the end final exam pay you need not worry anymore. Thank you. Okay, so that's all for today. See you all. Good night. Okay, what is the problem in the ROM sum? And here, if you have doubt, please ask me when I'm explaining the same. Don't ask me after completion of that. Okay, at the explanation, every time I'll ask you whether it is clear or not. Please tell me what is your problem. Please ask. I can help you. No problem. Kindly please respond fast. See, yesterday class, I don't have that notes. Okay, so I cannot help you that. Yesterday class, year before yesterday class, all those things, you should attend the classes on live. Okay, if you miss the class on live, definitely you will be missing something. So what I have discussed yesterday, how could I remember now? Okay, come to classes on live यार आप लोग तो बहुत busy है जो those who take the classes we are free every time to take class anytime, but you people are very busy. You can't attend the live classes. You can watch it in recorded whenever you have time, whenever you have mood. Then whenever you get the doubt, you can come in any other class and asking the doubt. That is not fine. Please understand. Maybe you're asking this question. When two functions are implemented using ROM, I'm not sure you're asking this or not, but I assume. So how many functions you are implementing, those many OR gates you should take. So I have taken in that question 2 power 3 by 2, where 2 is the number of OR gates, 2 power 3 is the number of lines you are getting in the decoder. Maybe you are asking this. 2 power n by m. M is nothing but number of functions or number of bits you need in the output. Okay. Is it okay? Yes, m is nothing but number of bits in each location, number of functions you need to implement, or number of output bits. All are same. Okay. Okay, thank you. Also, there is a new series started here, top 50 questions of this month. PYQs. I'm solving on the special class platform. आप लोग मेरा special class में join. मेरा link is मेरा profile link is available in the description. Join my special classes. I am taking one class already. I have taken one class on networks. Tomorrow also I'll take one class of the network, and day after tomorrow, maybe Monday, Tuesday also, I'm planning for digital classes for classes on digital circuits also. Okay. See you all then. Thank you. You can join my Telegram channel Shankar 10 for more updates on notes, etc. Okay, thank you. ABC is the 3 bit that will give you the number of input address bits. 3 bit is the address bits, 2 power 3 is the locations, and 2 bit is the output bit.